All right, fine. So, so someone asked me to introduce that idea of that coordinate system, right? We already talked about first one is, say, if I say that Cartesian coordinate system or rectangular coordinate system, this one is, say, Cartesian coordinate. There's, in the three-dimensional case, we express that from right. So I just give you the summary. So this is my x-axis, this is my y-axis, and this is my, say, the z-axis. So then you can find out that if you want to find out a position into that. So this is that position. And we can find out that projection also in that. And say this is the P is the point, so the position of this point I can write x, y, and z, right? And we also say that the unit vector of this Cartesian coordinate system we express I, z, and the k head, right? And we know how to find out that point actually x, y, z, and also the component of this. And we also know that properties of this unit vector from for Cartesian coordinate system. Okay, fine. Then we're going to talk about, say, that second one. Say this is the Cartesian coordinate system. Second one is, say, that polar coordinate system. So in the polar coordinate system, basically, that's we already talked about that one also, because we only take that component in the 2D. Say this is my x-axis and this is my y-axis. So I choose a point over here. Say this is also the, say that the P. Then we can say we can use, okay, fine, I can use that line. So this is, say, that position vector P. But we are using, say, I'm going to express that point in a different way, basically. So although the in Cartesian coordinate system, I will find out that should be that point P. Then you can say this is to be your x and this is to be your y, right? But in the polar coordinate system, we express the other two variables that we talk about, basically, say that r, and another variable is that theta. These are the two, basically, that polar coordinate. And we know how to find out the relation between these two, right? We can find out this r would be basically, you can say that, or I should find out the in term of xy, so that you can understand. So x would be basically r cos theta, right? If you take the projection, and y would be basically that r sine theta. Then you can find out the r from there, which is basically that x square plus y square. And theta you can find out is tan inverse y by x, right? We already use this thing also for Cartesian coordinate system. Now the unit vector for this polar coordinate, remember this unit vector r would be basically in the direction of vector r or increasing direction of vector r, basically. Look at this. When you use that I head, we use towards the increment of the length x, right? Either towards that direction or towards the negative x direction. That is the direction of the unit vector, or vector itself, sometimes we say that. So that's why we can also use that. This is the incremental direction of vector r. And what is the theta? Theta is increasing towards that direction. So that's why I can say the theta head, which is also another unit vector in the case of polar coordinate. So that should be basically that theta head. These are the two unit vector for the polar coordinate. And we can also find out that unit vector of this polar coordinate, theta head and the r head, in terms of basically Cartesian coordinate system. I'm not going to go for that one. Do you want to see that one? What would be the value of polar theta head and the r head? Should I show that one? If you want, then I can show you basically. But that should be not required for this course. Do you want to know what is the theta head and the r head?
Yes, sir.
Yes, sir.
Okay, fine. Look at this. We can find out. It's a very straightforward. I'll define, say that r head would be vector divided by vector magnitude. That's it. This is the definition of the unit vector. Then what will be the r head vector? Sorry, r vector. So this is vector, right? I can write down using the vector triangle law xi head plus yz head. That will be my r vector xi head plus yz head. And what will be the magnitude? Magnitude I already find out, right? So, or you can say that only basically that would be that r. I write down that is basically that r. Now I can write one more line. Say x I can replace, which is that r cos theta I head plus r sin theta z head divided by r. Right? Someone knocking. Then your r head would be cos theta I head plus sin theta z head. So this is to be your r head vector. So that's when unit vector in the case of polar coordinate system. What about theta head? Theta head I can find out basically using the another condition actually. So what I will write down the theta head, I can write, so it's with the minus r head into k head. How I write down? Look at this. In the case of Cartesian coordinate system, I have three unitary vector I, j, k, right? And in the polar coordinate, I have also said that r head, theta head, and also the k head. K head is perpendicular to this because r and theta in the xy plane, right? In the three-dimensional case, then I'll also find out one more dimension, which is would be basically out of the screen. If you look into that screen or out of the page, sometimes you can say that. So that's why I'll also use that properties. Say if I say theta head r cos k actually. So that's how I can write down in that form. I'm using same thing, the properties of unitary vector. So since theta head, I am writing this r cross this one. I'm going to the clockwise, so that's why I use the minus sign over here. I'm using the same idea for the Cartesian coordinate system over here. Then you can write down. So because I know that I find out that r, right? I know that the unit vector of r, which is actually that cos theta I head plus sin theta z head. Now take the cross product of k head with that. Now what will be that theta head? So theta head, if you do that, look at this. I cross k, what will be that? If you take I cross k, that will be the minus j. Am I right? I'm using that. Look at this. If I go to the counterclockwise, I cross j would be the plus k, j plus k would be the plus I, and k cross I would be that plus j. But if I move to the clockwise direction, say I'm using for, so for this counterclockwise direction, I will find out the plus. If you move for that clockwise direction, you will find out the product would be basically the negative. So that's why in a case, if I write down, so I'm going to multiply this one, right? So cos theta I cross k. So I cross k, I'm moving to the clockwise. I'll find the minus j. So that's mean I'll find out minus j into cos theta plus j cross k. J cross k is I'm moving to the counterclockwise. Now I will find out the plus I. So that's why I write down the plus theta sin theta I head. Now you'll find out this theta head would be basically your you can write down in a form minus sin theta I head plus cos theta z head. So this is to be your unitary vector in the polar coordinate system. And this is also useful in the case of coordinate transformation. When you transfer from one coordinate to the other coordinate system, then you can also find out what would be that. If you know the unit vector, then you can also find out the other properties like the velocity, acceleration, forces for different coordinate system. And this is very interesting in the case of dynamic system. We talk about basically in the case of classical mechanics, we use that unit vector in the case of the polar coordinate system. Yes, any question over here? Yeah, let's talk about that cylindrical coordinate system. Cylindrical coordinate system. So in the case of the cylindrical coordinate system, basically, let's allow me to draw this coordinate system in the freehand. Instead of freehand, I can use this one. So this is my one axis. This is so I use this is my x-axis. This is my y-axis, and say this is the z-axis. In the case of this, say I have a position vector which I'm taking from this one. Say that point in the Cartesian coordinate system, I can find out, say that x, y, and z, which actually you can find out in the form. Say if you take that component in the, we can use basically the idea of this vector triangle law. We use, sorry, I can extend that. So right, say this is actually that we will move to the x coordinate towards the x direction, y coordinate toward the y direction, and z coordinate toward the z direction, right? So that's why you can say this is this length will be the x. If you take, so this is y, and this is your z, and this is actually the origin. Now in that case of cylindrical coordinate system, we use the variable. Say that one is called the rho, another is the phi, and is the z. Rho is basically this shadow which is in the xy plane. So this is actually the rho, this length, which create a angle, the phi. This is actually that phi, and this length which is towards that z direction, that will give you actually that point actually that in cylindrical coordinate system. So this is one variable which is the rho, another variable is the phi, and another variable is the z along to the vertical direction. So then we can also find out this quantity. Basically, say we can write down, say I can write down, say that x component. I can take that component initially, right? Say that first I can say that x would be basically that rho cos phi, right? This phi is creating angle with the x-axis. Then y would be basically that rho sin phi, and this z would be basically the z in that cylindrical coordinate system. And you can, in that case, you can also find out the value of this rho, phi, and the z. So rho would be in that case root over x square plus y square, and phi would be tan inverse y by x, and the z would be basically the z. This is actually the variable in the case of cylindrical coordinate system. And this the unit vector for this cylindrical coordinate system also we express by this three quantity, which is rho head, sorry, second one is phi head, and third one is basically the z head. And the direction of all three variable or all three unit vector would be in the direction of increment of this quantity. So increment quantity means you can say that in that case, say I can say that direction of this unit vector rho would be towards that direction, because this is the direction of increment of rho, and this is would be the direction of increment of phi, because phi is increasing in that way, right? And this angle is basically the 90 degree. And what is the direction of the z? So the direction of the z would be towards increment, z head would be towards that direction. So that's how would be the direction of this unit vector for the cylindrical coordinate system. And we can also find out that unit vector, I'm not doing using the same idea I use in the case of the polar coordinate. I will just write down, say that this rho head would be basically that vector rho divided by magnitude of that vector. Sorry, it's not unit vector. Sorry, this would be rho vector. Then you can find out this thing. So basically, I'm writing down. This is would be rho. I can write that vector x I head plus y z head. Rho vector basically, if I consider, say this is my, this vector is right now say the rho vector. Then this is xi vector and this is yi vector. Then rho vector would be xi head plus y z head using the vector triangle law again. Every time I will use that idea. So divided by, say I kept in the rho because that could be negative. Then in that case, x actually that rho cos theta. So I can write down rho cos phi, sorry, not the theta. The angle is phi for this case. I head plus rho sine phi z head divided by rho. In that case, you will find out that rho head would be cos phi I head plus sine phi j head. So this is with the unit vector in the case of cylindrical coordinate system. Rho and phi head you can find out using that same. So I'll write down z head cross rho head, right? Because they are also perpendicular. These three coordinate I draw is over here. Rho head, z head, and phi head are perpendicular to each other. Then we can use that idea also over here. Say that we can write, say, phi. I say that phi z head and the rho head. Using that idea, we can also write down. If you do that, I'm not going to do that. I hope you can do that. If you solve, then you will find out the same way. You will find out this phi head would be sine phi I head plus cos phi z head. So this is be your unit vector in the case of cylindrical coordinate system, and the z head would be basically that z head, or you can say that is with the k head. We express in that form for the cylindrical coordinate system. That's how actually you can express. What about that spherical coordinate system? Spherical polar coordinate or spherical coordinate is same. Spherical polar coordinate.
Sir,
So,
I have one question.
Sure. Go ahead.
Can you just go up the diagram? Yes. Yeah. The diagram. Yes.
Yes.
The Y. Did you write the Y?
Yes, it's a Y.
Yes, the Y part is on like the what, like where?
This this is a look at this. This projection is X, right? And this total projection will be the Y.
Oh,
And
okay.
this y is basically the axis I kept in, or I should use the capital X or the capital Y to overcome the confusion. Is that okay?
Okay, sir.
We're fine. Now for, say, I'm going to make this copy to draw that spherical polar coordinate system. It will help me. So I will fine. So a spherical coordinate system, we have variable is different basically. Say that word. Sorry guys. Okay, well, I can keep that way. Say this is my y. Now, in the case of the spherical coordinate system, we express that length is r basically, and this is the angle we keep the same, which is actually that phi. And this is one more angle we introduce for the case, which is basically that theta. These are the variable for in the spherical coordinate system. So then we express, there are some condition actually, or you can write down, say theta would be basically greater than or equal to the 0 and less than basically pi by 2. And the phi would be greater than 0 and less than equal to the pi. This is the case for the spherical coordinate system. And this theta is called the polar angle, basically polar angle measured from z-axis, and the phi is called as the azimuthal angle, locating actually in the xy plane actually. So then how I am going to find out this coordinate in terms of Cartesian coordinate system? Basically, our frame of reference, we are basically familiar with that Cartesian coordinate system, right? I'm going to transfer from Cartesian to right now that spherical coordinate system. So that's when I have to know that r, phi, and theta. Fine. Say first I can write, say my z component, right? I can write down my z component would be that r cos theta, right? Because this one create an angle with the z axis. Fine. Then in that case, I can say this is could be also that r xy. I write down the xy because it is in the xy plane. So that's why I write down, which is would be the projection of r in the xy plane. I write in that form. Then I can say rxy would be that r sine theta, right? We can find out easily from the component idea. Fine. Now this rxy is create the angle phi with that positive x-axis. Then I can say x would be rxy cos phi, right? And rxy basically that r sine theta and the cos phi. I just replace that rxy from this equation. So this is my value of the z component, and this will be my x component. Now, what would be the y in that case? Y would be r xy sine phi. I write down the sine phi because I know these all are right angle triangle or rectangular triangle. So that's why I write down the y component in that. Otherwise, if I don't know the angle between these two coordinate, then I will use that ratio of the cosine, cos of theta actually. I will use it in that form. But the rectangular coordinate system, I know that if the angle is going to be created with the some axis, the opposite axis would be sine ratio. So that's how we talk about for the case of component for the rectangular coordinate system. And what would be that? This would be basically that r sine theta sine phi. This would be actually that component of this Cartesian coordinate in terms of polar and spherical coordinate system r, theta, and the phi. Then you can also find out what with that r, right? What with that value of r? R would be basically, I'm just squaring all that term, right? So this term, if you do that, you can find out, say this is would be x square plus y square plus z square. Take the square of this one, and that one. You can find out r would be that one. And in that case, your theta would be right now tan inverse r xy divided by z. I'm talking about the theta, this one. So then this is actually the rxy. That length is also that rxy. This one and this one basically the same. So then this is theta, so it would be perpendicular rxy divided by base. So that's why I write down rxy by z, and rxy basically root over x square plus y square divided by z. This would be the theta, and the phi, you can write down the phi, which would be tan inverse y by x. Phi you can find out from that. So this is actually your phi angle, this is your x, and this is actually your y, since this is actually the y. We can find out from that trigonometric definition. So that's how actually you can find out that variable. And by the same analogy, actually the unit vector, in the case of these three, it would be, if you want to draw that direction of this unit vector, I'm going to draw. Say this r head would be in the increment of the direction of the r. So that's why this is would be the direction of r head. And that theta head would be in that form, it's a downward. In that case, the theta will be the increase, and the phi head would be towards that direction. So this is to be actually that direction of this unit vector, r head, theta head, and the phi head. And we can also find out that value of using the same analogy I talked about. I just write down that value. What is that r head? It's a weak equation, basically that sine theta cos phi I head plus sine theta sine phi z head plus cos theta k head. This would be the r head, and the phi head would be minus sine phi I head plus cos phi z head, and the theta head would be cos theta cos phi I head plus cos theta sine phi z head minus sine theta k head. So this would be actually the unit vector in the case of spherical coordinate system. So do you understand? So that's how actually we can transfer from one coordinate system to the another coordinate system. If you know that very well, and if you know that unit vector, then you would be also able to find out that velocity, position, acceleration, forces, any other quantity in that this coordinate system. This is actually the general idea we can you can use for any other coordinate system, actually the same way. So this is actually that different coordinate system we should know in the case of dynamic system. Yeah, fine. Any question over here?
No.
Although, don't be afraid, guys. There will be no, basically, the spherical and cylindrical coordinate system in your exam. There will be, we'll only talk about basically your polar and spherical Cartesian coordinate system. No cylindrical and no spherical coordinate system in this Newtonian mechanics.
Down a little bit, I can see the diagram clearly.
Which one? This one?
Yes. Yes.
So I just talk about because someone want to know this one. So that's why I give you that idea how we can deal with this cylindrical and spherical coordinate system. But this is very interesting in the case of dynamic system. You have to know that, especially those mathematicians they have to know for the dynamic system, and those who are planning to study about the robotic engineering, those who are from engineering faculty, definitely you should know this dynamical system or the different coordinate system. So it's very helpful. And also for electrical engineer, when they talk about basically, when they learn about the waves and field, they have to also know this cylindrical, and they have to deal with these two coordinates, cylindrical and the spherical coordinate system also.
So also for maths department.
Yeah, also for math department.
Or
Physicists and math, they will learn this thing. For the physics student, they learn actually basically in the classical mechanics. This thing they will talk about in the case. And this course is running in this semester. Classical mechanics is a physics 204, and mathematician also talk. They learn this thing actually in the dynamical system. This thing they learn this thing in the dynamical system. Yes. Any more question over here, or can I go my real topics today?
so no question, I think.
Okay, fine. We'll come to this our vector problem, actually the traditional problem we talk about in our classes and exam, which I mostly dislike this traditional problem. I don't like this at all, but I have to do that. No other way, because they will give that type of question in the exam. I hate that typical question. Yeah, fine. Look at this. There are three vector, A, B, and C. I'm sorry, I just write down, guys, by my hand because my handwriting is not too good. So try to cope up with that. I'll try to. I promise you, if you come to in the next semester, I'll try to improve my handwriting.
Oh, sir, it's fine. It's actually.
Thank you very much. So fine. So this is three vector A, B, and C, which is in the Cartesian coordinate system. And first question they asked me, in unit vector notation, what is R, which is a new vector, if R minus A plus B minus C equal to the 0? Remember, when they talk about the unit vector notation, that means they're asking to find out in terms of I, J, K. Right? So that is the meaning of the unit vector notation. But if they ask you find a unit vector in the direction of R, that will be the different, right? Which is not is I, J, and K. So R vector has a direction, that would be the direction of unit vector of R, which would be in the direction of vector R itself. So they are not asking, but most of the guys, they do that. When they see the question mention the unit vector, they automatically define or automatically write that formula, unit vector, this one, say vector by vector magnitude itself. Remember, this is the unit vector in the in the direction of vector A. They don't ask you to calculate a vector in the direction of vector A itself. You don't have to find out that one. You can express in terms of unit vector means I, J, and K in the Cartesian coordinate system. So try to understand the question when they will ask in the exam. Fine. So how I'm going to find out that A? So vector A. So I'm writing that solution. They said that R minus A plus B minus C equal to the 0, right? Then what will be that R?
R equals to A minus B plus
A minus B plus C.
Now, should I calculate that one? What is that? What is that? So this is actually
again.
It is basically addition and the subtraction, right?
Yes, sir.
So which is unfair for you, I think, at this level. If you ask you to calculate A minus B and plus C, is, I think, unjust. So I hope you can do that. If you do that, I'll just write down the answer. So they will check whether you can add and the subtract more than 2 or 3 vector at the same time. So this is actually the target of this question. So in that case, you will find out a 11 I hat plus 5 j hat minus 7 k hat. So this is the answer of the first question. It's very straightforward. I hope you can answer. You can find out. So second question,
Sir, may I ask?
calculate the angle between the vector A and B. I have to find out the angle between the vector A and B.
Sir,
Yes.
for these sort of calculations, if I use matrix to represent them, that wouldn't be wrong, right?
Yeah, definitely. Definitely. Vector is also, you can do that in the matrix representation, which is very interesting. Which is also, it's basically the linear algebra, right?
Yes, I
So
mean, that way I won't have to place I, j, and k each time. So
no. If you want to express, that's different issue. Mathematician use basically the matrix representation, but when you deal with the vector, you have to express in terms of I, j, and k.
okay.
Matrix representation is a different thing. When we talk about only for the magnitude, so then we can use say a large number of data. When you're going to dealing with 3 by 3, or sometimes you have to deal with, in the case of matrix format, 9 by 9 matrix, 6 by 6 matrix. It's a huge volume of data. So fine. So this is would be that. Second question, they asked me find out the angle between the vector A and B. I'll write down the A, B, cos theta, right? And remember, this is most reliable formula to find out that angle between that two vector. Any vector, if you know that two vector in terms of 2D, 3D, if it is more than 3 dimension, then you can also use this inner product or the dot product or scalar product to find out the angle between that two vector. This is very useful, very powerful tool or powerful formula. Fine. So if I do that, I can find out that angle basically, right? So what would be that in that case? I just write down, so cos inverse A dot B divided by magnitude of A and the magnitude of B actually. So then I can write what would be the A dot B. Look at this. If you want to find out A dot B, basically I dot I would be the survive, and Z dot Z would be the survive, and K dot K would be the survive, right? Rest of the thing would be basically that 0. Then I can write is going to be basically minus 10 plus 8 and minus 18. And the magnitude of A is root 77 and magnitude of B is root 17. Then you can find out the angle. So theta would be basically 123.55 degrees. So this is the answer of the question number B. I hope you can do that dot product. So look at this, 5 into minus 2, which is minus 10. I write down the minus 10. 4 into plus 2, which is plus 8. And minus 6 into plus 3, which is minus 18. So that's why I write in that form. Fine. So this is the question number B. Question number C, what is the component of vector A along the direction of vector B? Try to understand this one. Say I have these two vectors. I don't know which direction it will be, whether angle can, I know that the angle between these two vector A and B, right, is 123. Say this is the vector B. The angle is theta between them, which is 123. Then I have to find out the component of vector A, right, along the direction of vector B. Look at this. This component of vector A along the direction of vector B. How I'm going to find out that one? So I know the angle over here, right? Angle is theta. So then I can take the projection of this one, which would be towards that direction, it's going to be basically that A cos theta, right? If I take that projection. So then I can write down that A cos theta. I know that the magnitude of A, which is root over 77, and the theta is 123.5 degree. So if you do that, then you will find out this is will be that minus, right? Because cos 90 greater than is basically going to be that minus. So you will find out this would be the minus 4.85. It's a negative, basically it should be towards the opposite direction of vector A. So that's why, or opposite, yeah. So this is actually the direction of A, it would be towards that direction. So that's why it's a minus. You can do another way, A dot B, basically that AB cos theta. I can also find out that A cos theta from there, which would be A dot B divided by magnitude of V. And you can find out. So this is going to be that minus 10 plus 8 and minus 18 that I write down in the previous case. This one, A dot B divided by magnitude of B, which is root over 17. This is also give you the same result, 4.85 A cos theta, which is the component of vector A along the direction of vector B. This is the answer of this third question. Second question, what is the component of vector A along the perpendicular direction of vector B, but in the plane of A and B? A, B would be in the, basically, that component would be also in the same plane, the plane of A, B. It's not would be perpendicular direction actually. So this is would be basically the A sine theta, right? So this is would be that A sine theta, because along to that direction we write down the cos component, and this is asking about that perpendicular direction, which should be set toward that direction, or you can draw in that form that we talk about. Say it's not a greater than 90 degree, then it would be helpful for you. Think, say this is actually that vector A, and this is the vector B. If they create the angle is theta, then we say that this is actually that component A cos theta, and this is would be that A sine theta, which is perpendicular to the direction of vector B. So that's why I write down the A sine theta. And A magnitude is again 77 into sine 123.5. I find out that angle. In that case, you'll find out that length would be 7.31. You can also find out using cross product idea, A cross B. I'm taking the magnitude. So there needs to be the magnitude of A, magnitude of B into sine theta. So that's when I'm taking only that A sine theta from there. This would be that A cross B basically divided by magnitude of B. That will also give you the same result, 7.31. You can check that if you don't believe my answer. This will give you the same result. So this one is the question answer is D. Now we is say that calculate the angle between the vector R and the positive Z axis. Now for this one, say I'm going to draw that vector. So it's a rough sketch I'm going to do so that you understand. So this is your x-axis. So this is actually the z-axis. I'm leveling that thing. So this is x, y, the z, right? Look at this. My vector r is, what is the coordinate of the vector r? It's a 11, 5, and minus 7. So that's when I have to move 11 unit towards the x direction, towards the positive x direction, plus 5 units towards the positive y direction, and minus 7 unit towards the negative z direction, or 7 unit, you can say. Say I move. Say this is any arbitrary point actually. Say this is a plus 11. Then I have to move, say that towards that direction. Say this is that plus 5 towards the y direction. and also that -7 towards the negative z direction. So that's mean I have to move to the downward, right? Say this is actually that point. Say it's a 7. So that's mean this point, I can say the coordinate of this point 11, then 5, then -7. So this is my coordinate. Now I can draw this vector, say using different color. So what would be that? This one, right? So this one, I have to find out the angle between that one. And it's basically the downward, so which is not in the xy plane, below the xy plane. You can find out because I moved towards the negative z direction in the 7 unit. Although the drawing is not clear, but it would be basically fine. So now I'm going to find out that angle over here. I said you, if you want to find out the angle, this is the question number, probably the E, right? So I said you always you have to use that formula. A dot B is basically that AB cos theta. I'm going to find out using angle between the two vectors. Always I use this formula. Now my one vector is R over here, which is that one. I represent by that point, say 11 I hat plus 5 Z hat minus 7 K hat. This is my first vector. Then what is the second vector? Second vector I can consider, so there is a unit vector which has a magnitude is unitary in the direction of Z axis, right? Which is K hat actually. Then I'm going to use that one. Say in that case it will be the R dot K, magnitude of R, magnitude of K into cos theta. That will give me that angle which will be that theta between the Z axis and the R vector. So then you can find out that theta would be cos inverse R dot K divided by magnitude of R and magnitude of K. I know the magnitude of K, right, which is basically that 1 because it's a unitary vector. And the R dot K would be basically, what would be that? I'm going to multiply. And so if you take the dot product with that, with K hat, I dot K is 0, Z dot K is 0, K dot K is basically 1, right? Then it will give me basically that -7 divided by magnitude of R would be 195. You can check that. And magnitude of K is basically the 1, right? Root 1 basically. If you want to write, then root 1 basically the 1. Then this angle, the theta would be basically, it's a 120.08 degree. That's with the angle between that this vector R and that positive zx. I can find out with any axis in that way. So if they ask me with the y-axis, if they ask me with the x-axis, or even they ask what is created with the negative z, negative x, negative y, with any axis I can find out with any vector in that way. So that's why he said that this formula is a very powerful formula. Okay, fine. Let's go for the next one. If calculate A dot B cross C. Also mention the dimension of this quantity. So if they ask me calculate A dot B cross C. Right. So what would be that one? So first I'm going to find out that the B cross C. Then I'll find out A dot. So if you do that, B cross C, so I hope you can do that. This is the determinant process, I, J, K, and that vector B coefficient is -2, +2 into 3, and the vector C coefficient are 4, 3, and the 2, right? Fine. Now what I'm going to do, I'm going to take that cross product. I know you know that. So this is the I. In that case, it will be the 4 minus 9, right? Plus, I'm using the plus sign. You can use that minus sign. Then you have to reverse that order. This will be that 12 plus 4 plus k will be minus 6 minus 8. That would be give me actually that B cross C. If I do that, B cross C would be basically minus 5I hat plus 16J hat minus 14K hat. So this is my B cross C. Now A dot B cross C. That's the vector A is plus 5I hat plus 4J hat minus 6K hat. So this is the vector A dot minus 5I hat plus 16J hat minus 14K hat. I just write down side by side. Then if you do that, this is a dot product right now, is that right? So I dot I will be the survive, but I dot J, I dot K will be the vanish. This similar identity will be the cancel out each other. Then it's going to be the minus 25 plus and plus 64 and minus plus, that's going to be that 84. 6 into 14. In that case, you will find out this will be the 123. This will be the answer, is a scalar quantity. A dot B cross C. Then also say that, also mention the dimension of this quantity. Say if the vector A, B, C are length, then the dimension of this quantity would be that meter cube, right? It's a 3-dimensional. That will give you the volume, this quantity. I talked about this in previous case, actually. Fine. Do you have any question over here?
Okay.
No, sir.
It's very straightforward, right?
Sir, I don't understand the multiplication.
Which one?
The determinant multiplication.
For cross product?
Yes.
Yeah, it's a basically we talk about we determine. I don't know which process actually you say. You take that bar in front of that when you're taking the I component, 2 into 2 minus 3 into 3. Let's give that one, right? And the second case, when you take above that Y component, you use the bar over there, Z. Now you write, since I use the plus sign over here, so that's why I'll go from that way. 4 into 3 minus 2 into 4. So there is a minus of that one, and this multiplication minus 2 into plus 2, that will also give me the minus 4. That minus and formula minus is giving the plus. So that's why it's a 12 plus 4. And for the third one, when you take that Z component, then I'll write down. So this is that minus 2 into plus 3 minus 6 and minus 4 into 2. That's going to be the 8. That's how we find out the determinant process. It's come from basically the Cramer rule, or you can find out if you have two linear equations, then if you separate the coefficient of that equation, put into in that row by column matrix, then we can find out the determinant with that way. Or I talk about this, how we're going to find out that component in the another way in my previous lecture. So X, Y, and Z, that I also talk about. You can go through that lecture if you have any problem with that. Is that okay?
Yes, sir.
Okay,
Yes,
fine.
sir.
So this is one more problem. Say that there are 4 vector A, B, C, and the D in different position and different direction. They give the magnitude of A is 1.5, B is 2 is a meter, and C is 1 meter, and D is 1.5 meter. They actually find out the resultant of all 4 vector magnitude and the direction. vector A plus B plus C modulus, and also what will be the resultant direction of this vector. Fine. I said we can do that by the graphical representation, but for that one, you have to know that exact value. This I have freehand writing, right? I don't know whether this angle is 40 or not. I just write in that way. So if you want to graphical representation, then definitely you have to, that angle must be precise. Otherwise, you don't get the actual result. So for that reason, we are going to use the unitary vector process. What we'll do, we'll rearrange the all four vector into the origin in that way. So look at this. I can say that I can use different color. Shift the vector A over there. Right. So this is the vector A. I can do that without changing the direction and the magnitude. I can shift the origin of that vector anywhere in the space I want. But the condition, I cannot change the direction, and I can also cannot change the length of that vector. Without changing direction and the magnitude of vector, I can shift that vector anywhere I want. So that's when if I keep that direction and the magnitude intact, then I can just shift that position of that vector. So that's why I'm doing that thing over here. So this is a vector A. So then say, so this is the vector D. This is the vector B, which gives the 19 degree. And this is, we say that vector C, which will create that 25 degree over here. Right? Now I can take the component of all four vectors. So I can express the vector A in terms of component. It's with that A cos theta plus, sorry, I hat plus A sin theta J hat, right? Then I know the magnitude, which is the A is 1.5 and theta is, for this case, actually that 40. If I do that, if I put in that way, say 1.5 cos 40 degree I hat plus 1.5 sine 40 degree Z hat, you will find out that vector A would be 1.15 I hat plus 0.96 Z hat. I split that vector A. Now what about the B? Look at this. For the B, if you split that vector, one component will be towards that direction, another component will be towards the negative y direction. Right? So that's why I'll find out. So B cos theta I hat minus B sin theta Z hat. I use the minus sign because this is actually the downward towards the negative y axis. For the case of A, x component is positive and y component is also the positive. So that's why I keep right both the component of this vector is positive over here. So in that case, the B would be, if you just put the value, you'll find out. I'm just writing because my time is running out. So 1.9 I hat plus 0.65 J hat. So this will be my vector B. What about the vector C? Vector C would be the same way you can find out. So it's with the minus C is, look at this. This is the vector C, right? Which is the 25 degree angle. Then your x component is negative and y component is positive. So that's why I write down, I just put the value also. Then it would be 0.91 I hat plus 0.42 Z hat. And what is the vector D? Vector D is towards the y direction, right? Totally towards the y direction. This is the direction of the vector D. It has no y component, literally, right? Because if you take that, say that x component, dx would be basically the d cos theta, that theta which is create the 90 degree, and d cos 90 degree, which will be basically the 0. So that's why D has no x component. It is totally towards the positive y direction. So that's why it has no x component. Then I can write down the d is basically the magnitude is 1.5. I'll write down 1.5. So ahead. So this is my vector. So if I add all them together, say a plus b plus c plus d, I hope you can do that, which is actually the addition and the subtraction. If you do that, then your answer would be 2.14 I hat plus 2.23 z hat. So this is actually that vector in terms of vector. Now, if I want to find out the magnitude, I know how to find out the magnitude of a vector, right? I am going to take that modulus of that. That modulus would be 3.09. And what about the angle? So angle would be basically tan inverse y by x. So its angle would be 46.12 degrees. So this is the answer of this one, this question. So I just rearrange the vector. If the vector is that form, I can rearrange. I can take them in one origin without changing the direction, and the magnitude of that vector I can easily find out. Fine. So I have one more question actually, which is more interesting. So you have a cube. The length of one edge of this cube is the 2 meter. So that's when every length has a 2 meter. Now you have a, they asked me find out that angle between the face diagonal of this cube. Face diagonal means this, I'm going to represent, so this is a vector A, and so this is another vector is the B. I have to find out the angle between these two faces. What would be the theta? Do you have an idea what could be that angle? Anyone can make a guess? Any guess? Are you guys sleeping mode?
45.
45.
I don't know. I'm thinking.
You are thinking, okay, fine. Thank you very much. So look at this. First, if I can express this vector A and B, then I'm going to use that formula to find out that angle A dot B. A dot B would be basically that AB cos theta. That formula I'm going to use to find out that one. Now I know this plane, YZ plane. So I'm going to use a different color so that you understand. So this plane, YZ, and XY plane, this plane are perpendicular to each other, right? And this vector A in that YZ plane and B in the XY plane, it's a diagonal of this face actually. I have to find out the angle between these two vectors. Fine. So do you think that angle would be 90 degree? Although this plane are 90 degree, YZ and XY plane are 90 degree to each other. Will you think that the angle between these two vector A and B would be 90 degree?
Yes, I was thinking that too, sir. But
It could be.
Yeah, you are thinking. Yeah, it could be. Fine. That's a very good answer. Okay, let's see that. So first I have to express that vector, right? I know the length of this, each of the arm is the 2 meter, right? Then if I want to express the vector A, I have to go 2 unit towards Z direction and 2 unit also the Y direction. Then I can write down the vector A would be, or you can find out the coordinate of this point. The same way you can do that. So I should write down the coordinates. Say the point of this coordinate, what with that B point, I'm writing the coordinate of this point B is with the 0, 2, and 2, right? I don't have to move to the X direction for this B point. I have to move towards, say, that Z direction and the Y direction. Or you can come in that way. First go to the Y direction, then come to the Z direction. you can reach that point B. What about the C? C would be 2, 2 into 0. I don't have to move to the z-axis to reach the point. I'll first go to the 2 unit towards the x direction and 2 units towards the y direction. Your time is over, guys. Yes, your answer is
60 degrees.
Yeah, you're right. Very good. Thank you very much. That's a very good. Excellent. So can you give me 5?
Do we really need all these calculations? I mean, if I consider it to be a triangle, I mean BOC and then back to B, then the length of BO is 2 root 2, the length of OC is also 2 root 2, and the length of BC is also 2 root 2. Hence, this is an equilateral triangle.
Yes, that's right. That's right. I know that you use that geometric idea, right?
Yes.
I'm doing that vector idea because my job is to teach you the vector. How I can use that formula, I learn A dot B, when I can use that one. So I'm doing it that way, actually. I'm just sitting there. I know your answer is right. Excellent, that you use the idea of the vector. Sorry, geometric idea, actually. It's equilateral triangle, it would be definitely. So that's why the angle would be the 60 degree. Can you give me 5 minutes extra because your time is over right now? Can I proceed?
Yes, sir.
I just find out the vector, then rest of your job. So look at this, vector A would be 0, because look at this, I'm using the general way. This is the general way you can find out. So I have to find out that vector, right? So this is my final point. Then I'll write down, look at this, 0 minus 0 I hat plus 2 minus 0 z hat plus 2 minus 0 is z hat. So that's mean ultimately I'll find out this will be that 2z, sorry, it's a k hat, I'm sorry. 2z hat plus 2k hat. Right, this is that vector actually, 2z, that direction and that one. So this is the vector A. What about the vector B? So, and the magnitude of this one, what will the magnitude of vector? 4 plus 4 is 8. So that's mean the 2 root 2. What about the vector B? Vector B, I can also find out, say that 2 minus 0 I hat plus 2 minus 0 is the z hat plus 0 minus 0 is the k hat. Then I'll find out the vector B must be that 2I hat plus 2z hat, right? Then I can say that magnitude of this vector will be also that 2 root 2. Fine. Now I'm going to use that formula, my vector formula, A dot B, actually, that AB cosine theta. Then the theta would be cos inverse A dot B divided by magnitude of AB, cos inverse A dot B. Actually, what will be that? Look at this. This is my vector. If I write down, this is that Z dot I will be cancelled out, but Z dot J will be survived. Then K dot Z would be the 0, and K dot J would be basically that 0. So that's mean A dot B, if you do that, A dot B would be basically that 4, right? 2J into 2J, J dot J basically that 1. So then I'll write down the 4, and magnitude of this is 2 root 2, and magnitude of B also the 2 root 2. So then this 4 will be cancelled out. It should be cos inverse root 2 into root 2. That's mean the 2. It's a half. So that's mean your theta would be basically that 60 degree. Cos half basically that's 60 degree. So that's why your angle would be that 60 degree. So that's how we can use in our real life what actually that meaning this vector actually, how we can utilize this thing in our real life case. So there will be a homework for you. This one is the homework. I give you that coordinate of this 3 point. This is the origin, and you have the point A is 320, B is 460, and C is 130. It's basically the quadrilateral. So you have to find out the angle between the diagonal of this quadrilateral. But the angle, that angle must be the acute angle. So that's will be your homework, and this answer will be the 82.53. try your at your home. Yeah, fine. Thank you very much. I'm done with today. I didn't take the 5 minutes. I take the 4 minutes.
Thank you, sir.
Thank you, sir.
So do you have any more question over here?
No, sir.
So is this the same as the lecture 3 in US?
Okay, fine. Thank you very much.
Is this the same lecture
Sorry?
in BUX lecture 3?
No. Actually, probably your motion in the 1D motion. This is basically the problem solving class for your vector chapter. Today I just solved the vector,
Okay.
some question,
Okay.
so that you get an idea.
Where will I find this homework?
So do the practice at your home, so you will understand.
Sir,
So
where
this
will
thing.
I find this homework?
Where you will find out that
Homework.
homework.
Yeah.
So you will find out in the BUX there is a case for the suggested problem,
Okay.
probably. So from reasoning calculator worker book you can do the practice. Okay guys, thank you very much. See you in the next week. Be safe.